Everyone, so this is just me explaining quiz number 9. So the first question says, what two terms represent major categories of compounds? So I look at the first slide, and I literally see that the only two categories are ionic and covalent, which is also known as molecular, and it's right there, ionic and covalent, or ionic and molecular. Right? You'll learn about nuclear equations and empirical molecular formulas later. Right now, all you need to know is ionic and covalent bonds make up all compounds. All right. The next compound is ionic. So I have to go back and say, what's ionic? Ionic, as it says in the notes, is between a metal and nonmetal. So what I have to look for? A metal and nonmetal. The only metal and nonmetal is KCl. Right? K is here, and then Cl is there. Right? Red and blue will be ionic. So metal and nonmetal is ionic. Hydrogen is a nonmetal, nitrogen's a nonmetal, and carbon's a nonmetal. So it can't be these because these have two nonmetals. If you ever forget, look for the other categories and see which one doesn't belong. If you only see one answer that's a metal and nonmetal, it's probably the answer, right? For chemistry at least. So moving to the next one, which is number 3. Sorry, brain fart. 3. So over here. So it says which ones will bond when atoms are transferred from one to another. So the key word here is transfer. Whenever you see that word, you automatically know that it's ionic. Right? And again, ionic is metal and nonmetal. And the only nonmetal and metal is oxygen and strontium. And let me change the color so it's easier to read. So strontium is in red and oxygen's in blue. That's always going to be ionic when it's a metal and nonmetal. It's always going to be a transfer of electrons. Right, the next one is number 4. So it says, what occurs when potassium reacts with chlorine? Right, so first you have to figure out what are those elements. So potassium is a metal, chlorine is a nonmetal. So if I know it's a metal and nonmetal, I know it's ionic and electrons will be transferred. Right, so it's choice 3. Moving along for number 5. It says which formula represents a covalent compound. So what I know about covalent compounds. Covalent is two nonmetals. So which one has two nonmetals? It looks like choice 1. Let's double check. Hydrogen, is that in blue? Yes, it is. It's right here on the top. If I could just circle it, that'd be great. Hydrogen is here, first one, and iodine is here. So they're both in blue. So two nonmetals is always covalent or molecular. The other choices are ionic. Ki is ionic, KCl is ionic, LiCl is ionic. Right. Number 6, polar and nonpolar molecules. Right. So we should always just recognize that this is water. H2O is water. And we should also recognize that it has no symmetry, either up and down or left and right, either way. So if it has no symmetry, I can use the word snap. And going back to my notes here, I even see that water is listed as an example of a polar molecule, right? So even if I just use my notes, I can determine that it's polar. And if I know it's polar, it's always asymmetrical. So that one's number 3. Right? But if you don't want to refer to your notes, just always look at the symmetry of the molecule. That'll help you determine whether it's polar or non-polar. Right? Number 7 says, why is CO2 non-polar molecule? Or why is the molecule of CO2 non-polar, even though the bonds are polar? Right? So I go back to my notes and I see that CO2 is under the non-polar molecule, which means it has a symmetrical distribution of charge, right? So which choice is that? That is choice 1, right? So, and the reason why, I think I could draw it here. So the reason why the bond is polar is, oh, sorry, that's CO2. So the reason why the bond is polar is because it bonds between two elements, and that's a polar bond. I mean, yeah, polar bond, because C and O are not the same. And this is a polar bond, right? So again, bonds between two elements. So this bond here between O and C is polar. because O is pulling harder, or one element's pulling harder. Over here, O is pulling harder. But since the entire molecule is symmetrical, it's going to be non-polar. Right? Hopefully they understand that. Maybe more practice. Watch the last puzzle video that I made. All right, this one here. Is this molecule symmetrical? Well, let's see. Is it in the examples? Can we cheat? Oh no, I don't see C2H2 in my examples. So let's look at the symmetry. All right, left and right, I have C and H, and on both sides, up and down, I have nothing. So that means it's symmetrical, which means it's non-polar. Okay, let me know in mind if you didn't get that. You should have gotten that. The next one is number 9. It says which one represents two polar molecules? So I could just answer this by looking at my examples here. So I see H2O and Cl. Oh, I don't see HCl. Well, I see H2O as a polar molecule. So I don't see HCl. So let's see if we use process of elimination. CO2. Oh, CO2 is always nonpolar. So if I'm looking for two polar molecules, it can't be this, can't be that. And then I see CH4 is listed here, which is a non-polar molecule. So I can eliminate this. But why is H2O polar? Because H2O, it looks like that, and it's not symmetrical bilaterally, up and down. It has, well, down it has 2 hydrogens, but up it has none. And then HCl, to the left I have H, to the right I have Cl. That is not symmetrical. That's not the same element left and right. So two polar molecules that are asymmetrical are H2O and HCl. Right, the next one. Which form represents a non-polar molecule? Right, so again, non-polar means symmetrical. And I could just look at my examples and just see that CH4 is a non-polar molecule. Or I could remember that if it has all the same atoms up and down, left and right bilaterally, it'll be symmetrical and nonpolar. So since this has the same molecules, or same, I'm sorry, not molecules, same atoms of hydrogen up and down and left and right, it's a non-polar molecule, right? And that's CH4. And the rest are polar. All right, so let me know if anything wasn't clear. Thank you for watching.